In problem 9, we're going to be writing complex numbers in exact form, and I've included the worked example for problem 8 so that you can see some additional examples of how these problems are worked out and what the final form is. So let's take a look at part A, -4 times the square root of -25. Before we dive too much into part A, there's one piece of information that will be helpful to remember. And that is, in all of these problems, whenever we see the square root of -1, we can replace it with the complex number I. So you can see how that works in this problem here, in this problem here, and then the same thing in this problem here. So let's look at part A. -4 times the square root of -25, I can rewrite as -4 times the square root of -1 times the square root of 25. That's going to equal -4, and I'm going to put this I in parentheses, and then the square root of 25 is 5. So think of the I as a variable, even though it has some meaning, but in terms of how you work with combining it and moving it around, it kind of acts like a variable. So now we have -4 times I times 5. That will simplify to -20I. Here the square root of 32 is the square root of 16 times the square root of 2. And that is just 4 times the square root of 2. So it turns out we didn't have a complex part for this problem. That's okay. We just write it in simplified form. This one, 5 minus 2 times the square root of -25 over 10. So let's work with the numerator, and that is 5 minus 2 times the square root of -1 times the square root of 25. All of that is over 10, and that's going to equal, I'm going to come over here, 5 minus 2I times 5 over 10 equals 5 minus, I'm going to multiply the 5 times the 2, 10I over 10. Now, I want to write this as A plus BI, so I want to break up this fraction, and I can do that as 5 over 10 minus 10 over 10 times I, and then I can reduce each one. 5 over 10 is the same thing as 1/2, minus 10 over 10 is really 1, so I can just write this as 1/2 minus I.